All right, so we're going to do a few more problems. Since the video from the 11.4 notes dealt with a lot of these card problems, I'm only going to do a couple of them. Number 19 says, what's the probability of being dealt the King of Hearts? Now, on your homework, it's probably going to be a different card, but I'm going to go through, I'm looking for the King of Hearts. There it is. Now, if I keep looking for King of Hearts after I've pulled it out, there are no more King of Hearts. So in this problem, this is only one card in the deck of 52. So number 19, the probability of the King of Hearts. Well, there's only one of them, so 1 over 52. Number 20, it says you were dealt one card. Find the probability that it is a club and a spade. So one card, club and spade. Well, as I go through my deck of cards and I find the spade or a club, none of these are both club and spade. Okay, a card pulled from a deck can either be a club or a spade. So since there are no possibilities here, probability of club and spade is 0 over 52, or that just reduces to 50. Sorry, 0 just reduces to 0. Okay, so I'm going to do a few of these coin problems. I'm not going to do all of them. Some of them are very simple, but I'm going to look at number 22 first. It says a fair coin is tossed 2 times. Now, that's the same thing as if it was asking or telling you that 2 coins are tossed, okay? But in this case, a fair coin is tossed 2 times, and here's how they tell you the sample space. The first one's heads, the second one's head. I'm sorry, it's 1 coin. So the first toss is head, the second toss is head. The first toss is head, the second toss is tails. And so on. So the question is, find the probability of getting exactly 0 heads. Okay. Exactly 0 heads mean both tails. Okay. So exactly 0 heads means both flips are tails. Okay. Or T. So if I look at my sample space, probability of both tails or both no heads, all that's the same. If I look at my sample space, there's only one instance where that happens. So 1, a total of 4, it wants a simplified fraction. So 1/4. Okay, that one was pretty easy, but let's look at number 23. It's a little more involved. Not bad, but I still want to look at it. So 23. Fair coin is tossed 2 times in succession, just like before. That's what our possibilities are. Find the probability of getting a heads on the first toss. I'm going to write out my sample space. Heads, 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 tails, tails, heads, tails, tails. So the probability of getting heads on the first toss means that first one has to be heads. That only happens here and here. So there's 2 possibilities. So the probability of heads on first toss is 2/4 or 1/2. Okay. There's some more coin questions. We'll get to those, but these are the simple ones. And then they talk about some children, I believe. We're going to skip to the next page. We're going to do 26. I found all of these pretty straightforward, but this was the only one I thought might give you some trouble. So number 26. Okay. All right, so we have a family of 4 children. M is male, F is female. The question is, find the probability of selecting a family with exactly 1 female child. Yeah. So the probability, this is 26, the probability of exactly 1 female child. Okay, not at least. Oh, no, it is at least. At least, let me fix that. Probability of at least 1. Okay, at least 1 female. It's having trouble focusing. All right, so. That fixes it. Okay, so the probability of at least. All right, so all I got to do is count up all the ones with an F. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And that's the only case that there's not 1 female. So there's actually an easier way to do this, which we're going to learn in 11.6 or 11.7. That is at least 1 female. Probability of that is not at least 1 female, so no females at all, which would be only 1 case. And we would subtract that off from the 16/16, and that would give our answer. But this was fine. That's not too bad. But that's our answer. It wants it as a fraction. And then that brings us up to 28. I'll probably stop after this one for now, for this video. All right, so what they've done for us is they have listed out all of the, if we roll a dice, then these, if we roll a single dice twice, then this represents the first roll and then the second roll. So roll 1 and then another one. So there are 36 possibilities. They tell us right there. You could count it up. 1, 2, 3, 4, 5, 6. 2, 5, 6. 6 by 6 is 36. So that's where that comes from. The question is, find the probability of getting a second number that is greater than the first number. Okay. So since you've printed this off, you could probably highlight these. I'm going to not highlight it in case we need to make more videos. I don't clutter it up. But in this case, 1, 1 is the same. But here, 2 is bigger than 1, 3 is bigger than 1, 4, 5, 6. So we got these. And then here, 2 and 2 is the same, but these are bigger. These are bigger. And what we end up with is kind of this upper diagonal. So I'm just going to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 28, probability of second bigger and first is 15 over 36. Now, if I type that in, it tells me I'm wrong. The reason is it's actually the correct answer, but we got to simplify it. So I can divide this by 3. And so if you are kind of weak with simplifying fractions, let me show you what we could do. I type in 15 over 36, and I think you can see it. Then you get this decimal. The answer says no decimal, okay? So I do second PRB, and it spits out 5/12. So I would get in the habit of using that or checking that, because even though I knew my simplification was right, if I'm taking a test, I mean, I need to make sure. Okay, let me see what the next one is. I'm not going to do these. I've always found these are pretty easy for students. If you have any questions, let me know. You know what? Let's do 36. This video might go long, but I want to do 36 for you. And I'm only doing this because of the way it is laid out. It looks confusing, but it's really not. Okay. The table shows the distribution by age and gender of 29.0 million people. So it's a bunch of numbers. Most of these are not going to be important. The question is, what's the probability that a person in the region, okay, in the 25 to 34, okay, so it's this column, is living alone? Okay. So notice it tells us male and female, but the question they're asking just says person, so they want both male and female. Okay. So on 36, person means both male and female. So what we're going to be doing is looking at the total. So in other words, look at the total in the column. Okay. So in this case, we got 3.6 over 29. So the probability, and I'm not going to write all that out. I'm just going to write 3.6 over 29. See what happens if I type this in. It says a decimal is okay, round to the nearest hundred. Okay, so if I type in 3.6 over 29, I get this. I'm going to write this all the way out. 0.124137931. Now, it wants us to round to the nearest hundredth place. So we do have to do that correctly. So I got 0.124. Since the 4 is smaller than 5, I'm going to round down to 0.12. All right. I think there's one more of those. We're going to do that, and then I'm going to make a special video for this dartboard thing. Okay. So number 40. It's the same concept, so that's why I want to keep it on this video. It's another table. So citizens who've moved in 2004, categorized by where they moved and whether they were an owner or a renter. Question is, find the probability expressed as a decimal. Okay, so that's how we want our answer. Rounded to the nearest hundredth, which means 2 decimal places. That a randomly selected citizen who moved in 2004 was a renter, so probability of a renter, and moved within the same region. Okay, so the renter row is here. Moved to the same region is this column. So I'm just kind of finding where those columns and rows intersect. 18.7, 18.7. Now, the tricky thing here is it does not give us a total. Okay, so I need the total. The total is found by adding all of those up. On the previous problem, they gave it to us, but here I got to do a little work, so I'm going to write it down. It might not be a bad idea for the first time you work this problem to write it down, or for your notes to write it down. And then double check what you wrote. 11.6, 2.9, 4, 18.7, 4.6. Okay. So I'm going to add those up. I got 39.3. Since I had to add 6 things up with decimals, I recommend doing that calculation twice on the test just to make sure you don't make a mistake, because it's easy to do so. Okay, I got it twice, which means I probably am fine. So 18.7 divided by that, 0.4758 26972. So that's what I got. But it says to round to the nearest hundred. I'm going to round 2 decimal places. Since that 5 is bigger than half, we're going to round this up to 0. Okay. Yeah. So I'm going to stop the video there. The next one we're going to look at is a little tricky, so I kind of want to spend a whole video on